Greetings to all the viewers. In continuation to the earlier session, we are going to conduct the organic named reactions. This is a content retrieved from textbook of organic named reactions, which is written by Dr. Kavita Kothiredi Kota. Right? The session what we are conducting is able to explain order in reaction. Right? The series of sessions which are going to be conducted all are available at the channel called World of Competitive Chemistry. Not only this, whatever kind of chemistry content you want to retrieve, that is available at the channel World of Competitive Chemistry. Let me continue with the content order in reaction. Order in reaction, simply the in reaction, we can say pericyclic reaction. It is the part of pericyclic. Pericyclic reactions are said to be concerted reaction mechanism. It not exactly isolated. Those are said to be concerted reactions. Pericyclics are the part of that one only. And it is named after Kurt Alder. Alder is the scientist who introduced this reaction. That's the reason why it is named after Alderian reaction. He is the pioneer in the pericyclic chemistry in reaction discovered by Kurt Alder in the year 1943. It involves a reaction between alkene and alkene, which acts like a enophile, and allylic hydrogen can be taken out. That is known as an ene reaction. Generating new sigma bond formation is possible. That is proceeded with 1,5 hydrogen shift. Hydrogen could be shifted from first to fifth position. Substituted alkene as the final product. Substituted alkene generation is taking place with the double bond shifted to the allylic position. Double bond is shifting from allylic position. It's a kind of pericyclic reaction, proceeds with the high energy requirement, being shifting of position of functional group taking place. That's the reason why energy consumption is higher in rate. If you want to see that reaction, this is a kind of a double bond and this is a kind of allylic compound with the hydrogen at allylic position. Whenever these two compounds are supposed to be reacted at higher temperature conditions, so that delocalization of pi bonds taking place. Pi bonds are, this pi bond is able to migrate toward this side and generates a new bond formation, which is indicated with the black line. And here is the pi bond which already existing is moving and generating and absorbing this proton, so that here hydrogen shifted from this allylic position to this terminal carbon atom. Another edge hydrogen shifting is possible, and moreover, these hydrogen bonded electrons are moving over there, so that here the new bond formation, new double bond formation taking place. With respect to this existing one, this is said to be a allylic position, so that allylic bond shifting taking place, and this is said to be a kind of energy consuming process. The reaction involves interaction between the alkene, this is said to be alkene, and that is ene, allylic hydrogen containing compound, multiple bond containing this compound, both are enophile, you can designate, and the new sigma bond formation is accomplished in between these two components. The reaction is highly valuable for constructing complex molecular architectures. So many new auxiliaries, new architecture compounds will be framed by means of this Alderian reaction. Particularly, synthesis of natural products and even pharmaceuticals are better fabricated by means of this Alderian reaction. If you want to take this Alderian reaction, you may go with either carbon-carbon double bond, carbon-oxygen double bond, carbon-nitrogen double bond, carbon-sulfur double bond, oxygen-oxygen double bond, nitrogen-nitrogen, or else carbon-carbon triple bond as well. These many kind of double bonded compounds are susceptible to participate in an Alderian reaction. That's the reason why Alderian reaction having extended applications, extended compounds if formed. Obviously, there is a applicability of these compounds in various fields. You can notice this is the way Alderian reaction can be taking place. The reaction is facilitated between ene and enophile. Ene means alkene. Enophile is a allylic hydrogen containing compound. These two are to be added in the presence of Lewis acid. Lewis acid facilitate the rate of the reaction, that speed up the rate of the reaction. High yield will be accomplished if we are using catalyst. Low temperatures are sufficient. The tool to form a new carbon-carbon bond. This is the very important factor. A new linkage is obtained in between the two carbon atoms, so that complexes can be achieved, or else natural products will be generated. Right? Reaction mechanism. How can we understand the mechanism of the reaction? Being it is a pericyclic, obviously you can assume it is a concerted reaction. Involves six electrons moving in a cyclic transition state. Non-isolable transition state involved in this reaction. Pi electrons of alkene, pi 2s electrons of alkene will participate, and sigma 2s electrons of allylic hydrogen, and pi 2s of that allylic carbon atom. So these many kind of additions taking place in superficial manner. Proceeds thermally, heat-driven process being shifting of double bond taking place, new carbon-carbon bond allocation is required. That's the reason why here the consumption of heat is required. Aldrin reaction proceeds through the concerted pericyclic mechanism and simultaneous transfer of allylic hydrogen from one carbon terminal to another carbon terminal. So that new sigma and pi bond allocation is possible, which is indicated in a mechanism. HOMO, highly occupied molecular orbital taken at this terminal carbon atom, and LUMO, this is highly lower unoccupied molecular orbital at another carbon edge taken into the consideration. LUMO was taken for another olefinic double bond. They are supposed to be condensed by concerted mechanism. All are indicated with the dotted lines, and here the new bond originated between is indicated with a dotted line bond as well. So this is a transition state you can assume, and hydrogen is shifting from the top position to bottom, so that here the newly formed molecule in reaction transmitted product you can obtain. Interaction between the ene and enophile, when we are taking carbon-carbon double bond and with the allylic hydrogen containing compound, so that you can achieve the newly formed compound in this manner, right? Hydrogen transfer is a crucial step in this Alder reaction. Hydrogen transfer is most what significant step over there? Temperature effect. Temperature often these reactions are heated driven, so that temperature plays a vital role in accomplishing these reactions, so that 100 to 200 optimum temperature to be used in this kind of Aldering reaction. Catalyst, obviously Lewis acid is a driving force which used to shorten the reaction time and increase the reaction product, so that catalyst Lewis acid is most susceptible for the fostering the reaction, and it used to enhance the enophile and increasing the electrophilicity over there. Substrate scope. Here, allylic hydrogen containing component is most required. Alkenes can be taken, or else alkynes, carbonyl compounds also taken as the another double bonded compound. So this is the way combination taking place. There is a substrate flexibility. Aldering reaction is quite versatile. It is most oftenly applied kind of mechanism. So many new compounds will be originated by Aldering reaction within the laboratory, accommodating wide range of enes and enophiles. So that exploration is much convenient over this Aldering reaction. However, steric hindrance is the important restricting factor, so that certain extent rate of the reaction will be limited, right? Regioselectivity and stereoselectivity. The reaction can exhibit high regioselectivity and stereoselectivity, which can be influenced by the structure of the starting material. For example, if you are taking this maleic anhydride and a kind of a double bonded compound, these two compounds are said to be somewhat sterically complex in nature. There is a provision for two kind of attachments. Either hydrogen is going to attach over this carbon atom, and another terminal of the olefinic double bond will bind up with this carbon. This is said to be endocyclic transition state. However, the mechanism is also accomplished in another manner. If you are taking this double bond, this carbon is attaching over there and this hydrogen is attaching over there, exocyclic transition state is also possible within the ring system, outside the ring system. Both the provisions you can notice, but endo transition state within the ring system, there is a transition state able to give the measured product where this kind of ester linkage connected to the double bonded compound in the backside manner, so the dotted line bond indicated this will be the measured product with the steric constraints. However, Exocyclic transition state able to give the wedge bond containing new linkage between the carbon and carbon, which is sterically restricted one so that it is not most oftenly formed minute quantity you can notice. This is the way mixture of two products accomplished that purely depends upon its stereochemical limitations, right? Now you can clearly notice here is the double bond containing allylic hydrogen and the triple bonded compound taken into the consideration. It comes under the example for this aldering reaction, where you can observe 2 degree centigrade and aluminum trichloride as a Lewis acid catalyst, which facilitate the rate of the reaction. So that here the new bond formation, the shifting of allylic hydrogen takes there, and this is the way kind of aldering reaction accomplished. Apart from that, there is another provision also. This ester entirely that allylic hydrogen may shift it to this position as well, so that here another possibility will be there. Though another possibility will be there, this is highly restricted one, only 3% provision you can notice. That is because here the ester and this double bond, if synchronized in a same manner, same direction, for example, highly steric hindrance plays a vital role, so that is not yet all favorable. Rather, double bond and triple bond in a particular plane, so that both are planar obviously, and that able to generate the product and hydrogen shifting taking place in this direction, giving rise to maximum extent of product. This is also in accordance with the stereochemical perspective. Let me go with the another compound where within the same compound there is a provision for the double bond at the one terminal and the allylic hydrogen for in either terminal, so that the provision for the ring cyclization and followed by hydrogen shifting taking place, you can clearly observe here allylic hydrogen shifted to the Y and YH formation is possible, and this is olefinic double bond shifting over there, and you can notice the type of aldering reaction. This is intramolecular aldering reaction, and the same is extended for another say another intramolecular aldering reaction. This is the simplest example you can clearly observe. Let me go with another new example. You can notice here is the double bond you can observe, and here is the double bond OH. So with respect to this one here, the hydrogen. And if this is the case, here is the olefinic double bond, here is the compound with aldehyde functionality. And that is able to connect with this newly attached compound. Wherever ketonic functional group is there, that converted into a hydroxyl one. Wherever ester group is there, that remains as such. Here is the linkage taking place between these two. And this double bond is moving to another carbon atom. There you can observe the connectivity in between and the migration of the olefinic double bond to the terminal carbon atom, and this is the way product formation taking place wherever high stereoselectivity. You can notice 99% yield is generated over there, where you can clearly observe hydroxyl is going to the backward direction, whereas the group whichever present on this olefinic double bond is indicated with the wedge bond. This is where stereochemistry is properly satisfied, and moreover Lewis acid stannic chloride are taken into the consideration. So here is the product formation uh, in the context of Alder-Ane reaction. Typically, reactions are taken over there. Allylic hydrogen containing compound and that double bonded compound both are susceptible for the combination, giving rise to a cyclic transition state, and eventually you can achieve the product in this direction. So hydrogen shifting followed by a position of the double bond also shifted. So this is another example you can notice. And this is the molecule where the terminal carbon with the triple bond, and this is the kind of ketonic compound with the hydrogen. This is said to be, this is resembling with the allylic hydrogen only, right? So you can go for the enolization as well. Whenever enolization taking place, again here double bond OH, you can notice this double bond OH working like a allylic hydrogen, and this is a triple bond working in the Aldering reaction, cyclization taking place, eventually you can achieve the five-membered ring with the side chain ketonic group, and here is the formation of double bond H. This is the way internal aldering reaction is also accomplished, not only allylic hydrogens but also the enolic forms are treated as a allylic hydrogen that also participating in this ordering reaction. This extent of research exploration we already observed. That's the reason why there is a great scope for this reaction and eventually application as well, right? So it's a simplest example, simplest mechanism indicated for aldering reaction where allylic hydrogen containing compound taken as an ene and enophile will be treated with that one. There is a simple delocalization taking place under heat conditions, heat-driven reaction being it is. And there is a new carbon-carbon bond formation. You can clearly observe newly formed one and hydrogen shifting taking place, substituted alkene as the final product. Here is the cyclic compound you observe, and here is the allylic hydrogen containing compound. Both are connected in reaction. Endo-ene reaction is taking place, and this will be the suitable product for this reaction. By this, we concluded the entire reaction mechanism, examples pertaining to aldering reaction, and the session is continued with the applications of aldering reaction. Schnabel and his co-workers established an uncatalyzed intermolecular carbonyl-ene reaction, which gives the cyclopentene as a major product. Cyclopentene product formulation is established over there. Envelope like a transition state taking place. Envelope like a transition state taken over there, so that here a kind of five-membered compound formation taking place, so that here this is the important application in the perspective of laboratory synthesis of synthetic organic chemistry. Right, so here Scannable successfully achieved this final product over there. So this is the way they accomplished the larger organic entity by means of aldering reaction, taking this decane as the starting material. And another possibility for the aldering reaction will be you are observing this is a double bonded compound, and this is the kind of aldehyde containing ester. This aluminum containing complex will be taken as a Lewis acid, and cryogenic conditions like minus 78 degrees centigrade operated over. Mixture of two conditions, mixture of two products will be originated. You can notice the newly formed bond with the blue coloration. And stereochemistry plays a role, either front side methylation, back side methyl group orientation is observed. But the suitability for this stereochemical conditions will be wedge bond methyl gives the major product 91% it satisfies the stereochemistry and the compounder stability, right? So this is the way our product formation, which is accorded with this kind of what we can say intermediate, whichever generated like a transition state. There is a formation of transition state in a six-membered manner with this Lewis acid as well. So here is the eventual product that is 91% yield. So this is achieved by Lewis acid catalyzed carbonyl compound reaction, aldering reaction. Now, even in the natural product synthesis, aldering reaction is most pivotal in nature. It's the valuable synthon for the natural products manufacturing within the plant origin. They are able to construct the ring systems and functional group introduction is manner that is controlled under enzymatic conditions. So the terpenoid steroids are also synthesized by means of aldering reaction, so that you can extend the possibility of aldering reaction not only to the laboratory but also to the natural product origination within the plant origin, right? Pharmaceuticals, obviously, whatever compounds are generated, being it is a much scope for the exploration, much research already been completed. That's the reason why already established drugs will be their potential in the field of pharmaceuticals and key intermediates to explore more, and they will be lead compounds to introduce new drug compounds in the near future as well, right? Not only that, not only the medication, but also the materials and polymers can be synthesized by aldering reaction. So many polymeric substances you can notice over there, they are manufactured by the concern of aldering reaction. Your classic example for the Alder reaction is observed over there. You can take a propene and treated with ethene. There is a formation of butene is possible. In specific, one butene. And this is the simplest example. A lilic hydrogen containing maleic anhydride can be taken. There is a formation of product is possible. This is the way also you can achieve the Aldrin reaction. 2pi cycloaddition is the criteria over there. 2pi cycloaddition and moreover hydrogen shifting giving rise to bicyclic ring system. One is 5-membered and there is 4-member newly introduced in between. This is also the kind of older in reaction. Let me introduce historical content when it is introduced, from which time onwards we are continuing with respect to Alder in reaction. Kurt Alder, he is also known for the Diels-Alder reaction as well. First, to describe the yield reaction, Kurt Alder, this credit goes to the yield reaction invention, goes to this Kurt Alder only. That's the reason why, in order to give the recognition for him, that named after Aldrin reaction. Mid of 20th century, this Aldrin reaction came into the picture, and most of the pericyclic reactions are fostered by means of this Aldrin reaction, and synthetic organic chemistry play in the synthetic organic chemistry. Much more research carried by means of Aldrin synthesis. In conclusion, Aldrin reaction is most powerful, and moreover, it's a versatile tool for the chemist in order to introduce the new carbon-carbon linkage and carbon heteroatom bond formation as well. Utility constructing complex molecules underlines the importance in the field of academia and even in the industrial applications. A thorough understanding of this reaction mechanism and the scope for the exploration and applicability of these reaction products are very essential for advancing in the field of organic synthesis. That's the reason why the content of whatever we discuss now, that is Alder in reaction, is most versatile and most widely applied one and most scope given for the exploration in the further research. That's the reason why you can follow the sessions, a series of sessions, so that you will gain the sound knowledge in the field of chemistry for your examination point of view in the academics and also for the research point of view. Thank you very much for your patient listening.